Marcus, take it away.
Thank you very much. Hi and welcome to my Skill Me Up expert talk from SQL to R, where I will show you how you can leverage your knowledge in SQL or T-SQL to actually learn R. Because this was the path I took. I learned SQL first and then I learned R and was wondering, how can I do the things in R which I already know how to do in SQL? So the agenda is quite easy. We have two things there on the agenda. So the first one, oh, I do not show my screen. I have to show my screen first. So back again, welcome to my Skill Me Up expert talk from SQL to R, where I show you how you can leverage your knowledge in T-SQL to learn R. And this is the agenda for this talk. I will show you the introduction to R, how you can do things in R, and at the end we'll talk how you can integrate R into Microsoft's data platform, because this will most likely be a way how you roll out the R code in your enterprise by having it on one single place in the data platform. So what is R? R is a programming language. We could argue about that. It's from the data types are strong and dynamically typed. We'll see what this means in a minute in the first demo. It's a functional language, so you call functions and pass in parameters, and parameters of course could be calls to other functions as well. And the language is interpreted, so there's no compiler where you have to create an exe file or something like that. No, you have singing the scripts and run those scripts. What is really cool about R is that it's open source. I work a lot in the Microsoft Data Platform and I'm proud of the data platform community, but I think the R community is even better. They're really active and they're participating in developing, not only doing community stuff, but also developing R and the packages there. The bad thing about R is it's open source, so there's really no standard. We will see there's at least 4 ways of assigning a value to a variable available in R. At least I discovered 4. Maybe there are more ways, even more ways. So there's a little lack of standard, and all the packages have their own syntax and their own ways of writing things. So starting off can be a little bit of a trouble, but I will show you the first packages and how you can use them. Talking about packages is the way of why R is so popular, because you can enlarge the functionalities and capabilities of R by downloading and loading packages. The last time I looked it up was in November. In November, we already had over 13,000 packages. So 13,000 packages, each package consisting of not only one functionality, but several data sets in there. So it's really hard to get an overview about that. So I don't think anybody can have an overview about all those packages. What's really famous are the statistical packages. So R is used by mathematicians and statisticians. So you can do your matrix calculations, you can have your descriptive statistics calculated for you with the use of packages. And then there's a lot of packages for machine learning. I think this is also a way why this is so popular using R, because you have access to rather complex machine learning algorithms by just calling a function. And we will see one, and we will do a time series prediction in this 60 minutes, and I'll show you how easy it is. You're just calling the functions and then you get the predicted values back. And data visualizations, of course, because if we want to know something about the data, we have to visualize it. It's the only way to get a picture. I mean, we even say in English, I want to have a picture about the data. So of course we have to visualize the data. And I will also show you how you can do this in this 60 minutes. SQL and R have many things in common. So one is both are used by data people. If you work with data, you probably have to learn SQL in some case because you have to create a database, and it's also a good idea if you learn a bit of R because of the things I just mentioned: statistics, machine learning, and visualization. Both language has to enable you to work with data. Of course, you have functionalities to extract the data from somewhere, load it, transform it, analyze it. Both are in interpreted language, so no compiler, and both are available on Microsoft's data platform. So since version 2016 of SQL Server, Microsoft incorporated R functionality in most of the tools in the data platform, and I will show you some of those possibilities. So let's go to the demo. Finishing with the slides, we will do demo almost to the end. At the very end, I will show you the integration in the Microsoft Data Platform, and then I will wrap this up. So first demo in RStudio. So I have opened RStudio in here, so you can see here up there, there's RStudio. That's more or less the standard IDE integrated development environment. So you have to install two things. You install R as the environment, and then install an editor or IDE. And I would recommend RStudio. That's the most common, I would say. Both are open source, both are free, so you can just use them. In RStudio, we have the window split in 4 regions. So there's one thing in the middle here. This is the area where I have loaded a script, which I use to show you capabilities of R. If I execute something of the script, then everything will copy down to the console in here and execute. Then we see the results of the execution down there in the console. There's also a part here like the environment. So we see that there's a lot of data sets already prepared for my demo. I just loaded things here. This is telling me it's a data set, and it has 16,857 observations, which are rows, and 44 variables that would be columns if we compare this to what we know from tables on SQL Server. And the plot, for example, will be in the 4th quarter here. The most important thing in the language is how to write comments. And comments, there's only one way. You write the hash symbol, and the rest of the line is then ignored. There's no multi-line comments available, so if you have multiple lines of comments, then you have to begin every single line with the hash symbol. The first thing is an easy calculation. It's not really a calculation, it's a string, and I can have several ways of executing the string. I can mark the string and press either Control Enter on the keyboard or this little button up there. Then whatever I've marked will copy down to the console and execute it and evaluate it. And of course, the string hello world ends up as a string hello world. Strings can have double quotes or single quotes, which I really like because I always get confused in some languages. You have to use the single quotes, like in SQL and T-SQL you're using single quotes. In Power BI or Excel you're using double quotes. In R we can use both. And the next thing how we can execute this is not marking anything, just having the cursor in the current line, pressing Control Enter or moving the mouse up again and press Run will execute this line. So again, no matter how you quote your strings with double quotes or single quotes, both will work. Then I have really easy calculations here. 1 plus 2, of course, equals 3. If I execute this, oh, now I changed something here. Sorry for that. So 1 plus 2 is, of course, 6. 2 times 3 is 6. And 2 to the power of 16 is 65,536. As easy as that. We always see, obviously, that there's like one element returned. So this is not part of the result, but this is more part of the formatting. Is showing one result returned, and the result is here 65,536. Now coming to assignments. I want to create a variable called A, and I want to assign it the value SQL to R. I can do this with the equal sign. So one single equal will assign the value there. And if we go down there, we will see that there's now a variable A with the content of SQL to R. We can also use this little guy here. This is not lower or greater minus. This is an arrow, so pointing from the right to the left. That's why we call it left assignment. So everything standing on the right will be assigned to the variable standing on the left assignment. It is doing the exact same thing. And of course, if there's a left assignment, there's also a right assignment. And right assignment means that the value on the left is assigned to the variable on the right. Whatever you're using, I would recommend to stay with one single way of assigning variables. Don't mix up the equal and the left and the right assignment, otherwise your code will be really hard to read. The most common thing I see is the left assignment. R is a functional language, so there's also a function I discovered to assign a value, which is called assign. And I can assign to the variable A the value here. So this is doing the exact same thing like the lines before. And if I want to see the result of an expression, I just write the name of the variables, and then I execute this here, and we see SQL to R. define functions equal to R. I think I had marked something here. I think I marked this, and while I executed this, so don't mark anything here. And then if you execute this, then we can see the assignment is working. And this is the content of the variable equal to R. Be careful though, because with the assign function, you have to write the name of the variable in single quotes or double quotes. In quotes, that's the important thing. If you omit the quotes, so assign another content, if I do that, I get another variable. So I'm not assigning to the variable a, but now the assign function looks at the content of a. The content of a is equal to R. And that's why I created a new variable equal to R with another content. So be careful with that. So I would stay away from the assign function because probably I would forget the double or single quotes for the first parameter and then not assigning the values to my variables, but to different things. R is dynamically typed. So what I show here, this is not dynamically typing, but if we do an assignment like up there, if I do the assignment and I want to see the result of the assignment, I can put the expression in parentheses and then the assignment will be done and the result will be shown. And that's what I'm doing here. So I'm assigning to the variable a the value of 1, and then I can, so now we had a string, suddenly now it's an integer, and now I assign this code here. So C is the combine function. With the combine function, all the parameters, it can be an endless list of parameters, will be combined to an array, and this is then assigned to the variable a. So currently the content is 1. If I execute this line here, then a suddenly is not an integer anymore, but it's a numeric vector with 2 entries, 1, 2, 2. So this double point means that this column means that there's up to 2 values there, and the first value is 1, the second is 2, and we see the first values here in this list. I can, for example, but this is dynamically typed, so it means I can use the same variable and assign different things to it in my code, and it will work. I would recommend not doing this because, again, this will confuse you if you walk through your scripts and suddenly the data type of a variable changes. This is rather confusing usually. But R is strong type. That means if I have a variable a and a variable b, and a is has the content of 1 is a numeric and b is a string, if I try to calculate a plus b, this will end up in an error because there's a non-numeric argument to the binary operator of plus. So this is not, I can't do this. But of course, I can assign the value of 2 to b, dynamically typed. So I change the type, and now a plus b is working. R is also case sensitive, which drives me sometimes crazy because I try to avoid case sensitivity in my databases in SQL Server. But R is case sensitive. We cannot change this. So if I assign a value equal to R in capitals to my lowercase r here, a, and then I have another variable with a in capital letters, I see this is a different variable. So we have a and a, which is 2 different things. And it's hard to explain that 2 different things because telling you A doesn't tell you which kind of case it is, so I try to avoid case sensitivity. And there's a different variable with different content. So these are 2 different things, and I compare A with A. So the double equal sign means compare the value. It will return false because the content of A and A is different, small capital and big capital. There's a lot of functions there. I will not execute all of them. So there's a help function, or to see the contributors or the options. There's even a function to quit the session. So if I call this, Rstudio will end. I will not do this in my demo currently. And at the end of this file, I also have some descriptive statistics. So for example, we can calculate the mean. The mean is the average calculated by adding up all those values, 1 plus 2 plus 3 plus 5 plus 100. Divided by 5 because it's 5 values. And if we calculate this, we see this is 22.2. The median is error prone to outliers. So we can see that the majority of the values is like up to between 1 and 5. But we have one value of 100, and therefore the mean is 22. The median is the more robust average. So it's robust average. So it's not influenced by an outlier, because the median more or less, that's how I imagine what the median does, is sorting the list and picking the one in the middle. So 3 would be the median of this list, Now 3 is not influenced by the 100 out there, this outlier, so this is robust to outliers. And there's also ST, the standard deviation. We can calculate the standard deviation. There's many more functions, just to give an idea how easy it is to calculate stuff like that. So you don't have to know any formulas to calculate this, but just using functions. Data types. A lot of different data types. I mean, basically it's the same we know from databases or other languages. So for example, I can assign the value 1 to a variable, and then the mode of the variable would be numeric. I can assign a string with double quotes or single quotes. In both cases, it would be a character. Then there's the logical data type that would be in T-SQL, would be bit. Sometimes it's called Boolean or something like that. Here it is a logical mode. And then we also have the complex data types. So I, small I, means this is the square root of -1. I learned about that in school, but I forgot everything about that. But I'm glad I could do my calculations on complex data types here in R. For the most cases in SQL Server and many other relational databases, it's the case if the calculation does not result in a valid value, you get null returned. In R, this is more specific. So 3 divided by 0, that would end up with null in the most relational databases I know. But here it's not null, it's infinite, because that's the right mathematic definition of dividing something with 0 means it's ending up with infinity. And there's also this constant here, so we can refer to infinity directly by writing inf. You can then check if something is infinite or not. 4 is not infinite. 3 divided to 0 is infinite, and infinite, of course, is infinite. And there's even minus infinity, because infinity can be on both ends of the numbers, and we get this minus infinity here. The same things here. There's also not a number. If we divide 0 by 0, for example, this will lead not to null, not to infinite, but this is not a number. There's no definition for this number. So this is what we get here in R. And again, we have this different calculations, or we can check if something is a number. Curiously, if I calculate infinity minus infinity, this also ends up as a not a number, because 1 divided by 0, we've had this example just before, ends up with infinite, and if I subtract infinite from infinite, this ends up as not a number. There's also not a variable. This is also a value. Most if you load data from relational databases and they are null in the relational database, they will end up as in A as not a variable in your data frame. Then we can check it. For example, if infinite is infinite, this is true, not a number equals not a number is not a variable, and so on and so forth. You can play around with the script. I will provide you with that. Just choose me an email, or you can download it from the Scaling Up homepage. Anything else here? And then we have the metadata for the object. So there's A is assigned, or I assign to the variable A, I assign the value of the return value of the C function. We already have seen this. C is combining. C combines value 1, 2, 3 to a vector, and this vector is then shown as the variable A, and the mode would be numeric, and the class is also numeric. The structure shows me that is a numeric vector with 3 values, and the first values are 1, 2, 3. That's the same information we get also in Rstudio up there. But if you're if Rstudio is not available, you could also get this information by calling the structure function. Then we can convert a vector to a matrix. A matrix would be of the same, all elements in the matrix have the same data type. So this would be a numeric matrix, and it's a matrix. The class is matrix, and the structure would be, we have now 1, 2, 3 rows and 1 column, and the first values in the matrix would be 1, 2, 3. List is another object. List can combine other objects, so you can have a list of anything else. So there could be a vector, it could be a matrix, it could even be a list part of a list. In this case, I come up with a list containing only of one vector. This is telling me here there's a list of ones, only one element, and the one element is a vector with 3 indexes or 3 rows or 3 elements, and the values are those because I created the list dependent on this array. Data frame is the thing we will work in the rest of this show. Data frame don't tell anybody else, but a data frame is most likely that what a table is in a relational database. So data frame consists of different rows, different columns. The columns are called variables, the rows are called observations. That's what we have seen up there. So this is a data frame with 6,857 observations. We will call this rows in a relational database, and 44 variables, that would be the columns in the variables. And of course, not of course, but in a data frame, it's the case that all the rows within one variable has to have the same data type. It's the same thing, reminds us of a table. But there's another data type here, table. I guess that's the thing why they came up with a new thing, data frame. But data frame is what we know from tables in our relational databases. Get this, we see that the mode now is a data frame. The mode is a list and the class is a data frame, and the structure would be a data frame, 3 observations of one variable, only 1 column, 3 rows, and this is what the first rows look like of the first column, 1, 2, 3. So what can we do with the data frame? One thing is we can make up a data frame on our own by creating, with the combine function, creating vectors, 3 vectors, which I'm calling call1, call2, call3, because later there will be columns in the data frame, and that's what we see here. I use the data frame function passing in the 3 vectors, and what I end up with is a data frame. And this is really looking like a table in a relational database. So we have 4 lines. This is a row number up there. This is not part of the data frame. This is only part of the UI showing us that there's 4 lines in here, 3 variables or 3 columns named column 1, column 2, column 3, and that's the values in there. Then we can select parts of this data frame. So one syntax is using the square brackets. 3 and 2 would refer to the 3rd line and the 2nd column. So 3rd line, 1 to 3, 2nd column would be 32, and 32 is what we get returned here. We can also call for the whole 3rd line by omitting the column information. If you omit this, that means give me everything, all the columns. So if I execute this, we get the whole 3rd line as we see here up there, 31, 32, 33, and that's the same thing we got here. And it's even telling us that was the 3rd line of the data frame. For columns, we can do the same. By omitting the row parameter and the square brackets, we can see the whole of the 2nd column. If you do this, please be careful, because now it looks like it's a row, but indeed it's a column, it's a vector, and the vector is visualized in, like it would be, each by sidewise, but of course that's a vector going like vertically in our data frame. So 12, 22, 32 would be this column, the 2nd column, 12, 22, 32, 42. We can also refer to a column by naming the column's name, the variable's name. And in SQL Server or relational databases, usually we use the name of the table and then a dot and then the name of the variable. Sorry. And in R, it's not a dot, it's the $sign. The dot, by the way, is a character you can use for variable names. So variable names or table names or data frame names or whatever you create or function names can consist of a dot. So this is not, we cannot distinguish the data frame for the variable with a dot because it's not a reserved sign. So they used the $sign. df$2 shows us the same content like the previous code, the 2nd column, or we could omit the comma and only passing in 1 parameter in the square brackets, and that would mean I want to see the 2nd column, and we get the same result, except that this time we really see this is a column, this 4 rows with those values. You can also attach a data frame, so if you're referring to a column, then it will look for if this column is available or this variable is available in the data frame, and then show the content there and detach it again, or if you only have one expression and the one expression is rather long and also your data frame name, your data frame name is rather long, then you could pass in the expression a 2nd parameter to the width function, and as the 1st parameter the name of the data frame, and then you can use just a reference to call2 and it will look up it in the data frame. How can we add new stuff to a data frame? you see here is to add a column. So I created a fourth column, column 4, with the left assignment, and then sorry for that, with the left assignment, and then I combine those values, 4 values for the 4 rows for this fourth column, and then I use the functionality cbind for column bind. So I bind another vector to the data frame. I add the new column to the data frame, I would say. And now we see that the fourth column with those new values for the fourth column. As we've seen with cbind, we can bind columns. With rbind, we can bind rows, as you might expect. And this time I did not create a variable for that, but passing in the call to the C function, the combine function, directly as a parameter for the rbind. So total we can, of course, putting function calls as a parameter into another function. If you do this, we can add a fifth row here for this data frame. So we see this for a fifth row, which was not existing before. And how we can delete again. So one thing is I didn't show you before, we can have the minus symbol here. So if I pass in the square brackets, the first parameter is for the rows. And if I pass in a number and have a minus there, it will show me everything except for the fifth row. So now I get the data frame with except the fifth row. And if I send this back to my data frame, of course, the fifth row is gone. If I want to delete more rows, again, I can use the combine function. So I'm combining the values 5 and 6 to an array, to a vector, 2 values there with the minus sample. That means show me everything except for the fifth or sixth row. So this is really, if you know anything about or start knowing things in R, then you always can apply this immediately in other use cases. And the combine function is really your friend. Usually, we will not create data frames or data inside of R, but we will try to access data from the outside. One way, and the most common thing, is that people working with R will ask other people, can you please give me this as a CSV file? Because there's an easy functionality, I can then download the CSV file, pass it in one of my directories, set the working directory with this function setvd, and there's another typo, but I have to mask all those backslashes, so I have to double backslash to end up with one backslash for the setvd wd function. So I set my working directory, and then of course, for example, I can read CSV, use the function read.csv, which is reading the CSV file from the local working directory, which I just set up there. And this is the name of the file, which would be effect visualizations by date subcategory.csv. That's how I read this. And with that, I get a new entry here and have my data available as a data frame. But it can be complicated to ask people to export something. They have to export it, they have to pass it over, then send it to me, and I have to store it again on my machine as a CSV file. This is not good from a performance perspective because people are involved then uploading, downloading things. And of course, security issue could also be a topic here, because if you store the file in a file system, it's hard to control who has access to the files. So another way would be to load the data directly from your database. And there's a library available, one of those 13,000 packages I mentioned in the slides before. So library Odbc, if you don't have this installed, you can install it, install.packages Odbc, then it connect to the CRAN, the comprehensive R archive network, download the stuff for you and install it in your R environment. And before you can make use of the content of the package, you have to state this here, library Odbc. So I'm loading the library Odbc into the current working environment, and then I can use functionality there. And there's one function of the Odbc package, which is called Odbc Connect. And this is connecting me through an Odbc connection to my server. So I created with the Odbc command on my local laptop a connection, and I'm passing in the user ID read only, and I'm passing in the password in here because that's the way how I authenticate in this case. Yes, password is really my password, as this is a SQL Server database locally on my laptop. If you get access, physical access to my laptop, then I'm doomed anyway, so I don't care if this password is safe or not. So I create this connection, And with this connection in hand, we can use another function from our Odbc. This is SQL Query. Using my connection, that's the connection I just created, and then passing in any statement which the server understands. In my case, this is a SQL server, and in my case, this connection leads me to AdventureWorks, so that's why I can execute SQL stuff from DBO team product category on the server. And the result of this query is then returned into a data frame called team product category. If I execute this, we get another a data frame here with the content here. We can also do the same with different, of course, with different queries, and the queries can be as, oh, sorry for that, wrong key on the keyboard. And of course, this can be as complex as your database system understands. I can have a group by, I can have joins, I can have aggregation functions. Whatever your, in my case, SQL Server understands, can be used here as the second parameter for the SQL query.
So
There's a
when
question?
you, yes. So when you ran the select, I didn't see any data come back. Where does it, oh, there's no data.
Yes, there's data. If I just mark the data frame in here, execute only this portion, then, oh, okay, I have a problem in here, obviously. Could I execute SQL exec direct invalid objects team product category? Obviously, the connection is not leading me to AdventureWorks. So I would have to clean up my Odbc connection. I think it's the 32-bit. I'm always unsure what R is using here.
So the data would have been displayed here in this console.
That would be the result set. So SQL Query is connecting to the SQL Server, executing the SQL Query. Whatever is coming back from there is then stored locally in my R environment in this data frame.
Okay. No. Okay. So because I see 3 different windows, I was just curious, where would the data be displayed? Your result set. Where would it be displayed?
Yeah, like sorry for that because I've a typo in here, but if you're using this one, I can show the content of this data frame. And this data frame is now loaded with CSV. In the other case, if this would have worked, it would have been loaded from the SQL query.
Got it. Okay. Okay.
From that point on, as soon as it's in the data frame, I don't care. This is not a live connection. So if the data changes or I lose the connection because now I'm losing the connection to the internet, no worries, because the data is now in your data frame, and then we can work with the data.
Got it. Okay. Thank you.
Yeah. Thank you for the question. Then I can close the connection again. Maybe that's the reason I closed the connection. Was this the reason? I don't know. I think you got the idea. You can connect there, and obviously I have a problem with my Odbc connection. Otherwise, it would have worked. With the thing now in a data frame, I was curious, how can I work with the data? Because in SQL Server, I'm rather confident in querying the stuff, grouping stuff, filtering stuff. How can I do this in a data frame? And one important thing here is the head function. The head function returns the first 6 rows of a data frame. Don't ask me why it's 6, why it's not 5 or just 3 or 10. It's 6. That's the default. So what we're seeing here now is only the last 2 columns. You see the 6 rows here, last 2 columns, and this is only due to the huge font size I've chosen here, so everybody can read from my presentation. Usually people think I'm crazy if they look over on my laptop with everything so huge. It's not that I missed my classes or lost my classes, it's just for the presentation, so it's easier for you. So you see this is the other columns, and there's the other columns, and here we're starting. So head is returning an index 1 to 6, the first 6 rows, and with the content of the variables in this data frame. If you pass in an optional second parameter, like head1, we only see the first row. Or we could also query the tail and 1, so we would see the last row, and we're really confident this is the last row because the index here is 441. I know there's 441 rows in my data frame, so this is showing really my last row in there. Projection is the next topic. Projection is to select which columns, which variables of my data frame I want to show. And in this case, I'm using the square brackets again. And here we also can pass in the name of a column. With the combine function, I create a vector on column names. I have to put them indeed, I have to put them in quotes. Double quotes or single quotes is not important, and that's how I get only a list of those 3 rows. Again, from the font size perspective, maybe I make this a little bit smaller up there in this direction. So next time we query something, there's more space here. So we see the last column here. This was the, where is it? The sales amount, and up there is the other rows. Another package I want to introduce here is the dplyr. Makes it really easy to query, combine, aggregate stuff. So if I load this library, I have access to this greater, it's not a greater, I mean, that's why, to this operator. And the greater sign, of course, is already used in R. That's why we have to put it between the percentage signs to say, no, I don't want to check if something is greater, but it's an operator delivered by dplyr. And dplyr is like working with piping. So I have the whole content of my factory visual sales by date subcategory data frame, and I take the whole content of this and send it over to the next function. The next function is also part of the dplyr, the select function. And if you're used to SQL, select is how you select the columns you want to see. And fortunately, this function is saying exactly that. So we select the order date and the English product subcategory name and the sales amount without quotes, because now we are referring to names of variables. So if we do this, we get the same result set. Again, this is the order date, the subcategory name, and then the sales amount from the data frame. Ordering is also easy to do. So one way, is it order by? One way would to have the order function here. So I'm passing in the first parameter for the square brackets, always referring to the rows. And if I'm passing in the order, then it will order the rows, in this case about the sales amount. And as the second parameter, the square brackets are passing in, I only want to see these 3 columns. So if I execute this one, then we should see the biggest sales amount at the very end, and the more I query up, I will see that the numbers getting lower and lower. With the dplyr package, we can do the same. So again, sending over the content of the data frame to the select, and then send it further. Again, send this result to the arrange function. This is not called order or sort, it's called arrange. With arrange, it allows us to order the content of the stuff, so we get the same result, the biggest values at the very end. Filtering, again, more than one possibility. This case, I pass in the name of the data frame, the name of the variable, and then with the double equal symbol, I want to make sure that I only get the road bikes back. And for the column, I'd like the order date and English product category name and the sales amount. This time we don't get everything, but only road bikes, as we can see here with the last rows. We could also have, instead of the double equal sign, we could also pass in the in. It's the very same functionality like in SQL, where you can have in, and then you put in a list of values. That's what we're doing here with the combine function. And this time I get not only road bikes, but road bikes and mountain bikes delivered as a result set. Subset is a function from the base package, so you don't have to install anything here, and then you can pass in the name of the data frame and then an expression, and only if the expression is returning true, then the row will be shown, the observation will be shown. So again here. And for the dplyr package, we can have the filter function. So it's not called word, it's called filter. So select was the same like in SQL, arrange is the order by, and filter is the word clause we know from SQL. And that's how we can do the same with the dplyr package. Getting a distinct list of values, so I don't want to see any duplicates. I can use the unique function. Unique function makes sure that every row only appears once in the result set. To aggregate stuff, we can use again the dplyr package. And to show you, just for educational purposes, I came up with a simple data frame, one data frame, and the first column is called A, consists of these values 1, 1, 2, 3, 3, and the column B, which consists of 2, 3, 3, 5, 6, more or less random numbers. If we create this data frame, we see this is the data frame. A has 1, 1, 2, 3, 3. B has 2, 3, 3, 5, 6. And then I want to group this data frame. So with the group function, I group on the value A. And for the value A, we have several values, more than one value. For example, here, the value A is 1. We have 2 rows here. What shall we do with column B? Summarize means we want to aggregate, and the aggregate function will be the sum. So it will calculate the sum of B and name the new column also A, also B. So if this is working right, we should see one row with with number 1 in A, and 2 plus 3 is 5 in B. For 2, we only have one row, so there's nothing will change. And for the third example, we have 3 here. 5 plus 6 is 11, so we should see 11 for the value A if we group by this, and this is exactly what we get. So for the column A, we have 1, 2, 3. For B, we have 5, 3, 11 as expected. We can also do more complicated calculations. So for example, I have my factory reseller sales. I want to group by my English product category name, the same thing like we have had up there. But this time I want to summarize more complicated. One is I want to have a new column, which is calculated as the sales amount sum. And this is the sum of sales amount, like the sum of B up there. You already know this. But then there's something different here. We also have the sum function, but this time I passed in the name of the data frame as well. And if I do this, now the sum will not be per value A, per grouped value, but for the whole data set. So I get the sum of the sales amount for the whole data frame. And I can use this as a single column to show. But of course, we can also use this in calculations. So I can divide the sum of sales amount per category by the sum of sales amount for the whole data frame. Multiple by 100, we get the percentage of how much sales we had for this example. So we have, for example, for the bikes, we have this amount. For accessories, we have this. This column shows always the same numbers because that's the sum of all the values here. And here we get the percentage. So the majority of values of sales was for bikes, 63%. The components were half of that, 16.8. This is half of that, 63, 33. Yeah, this should work. And then we see the small numbers here because this is rather small in sales for accessories and clothing in my example here. By adding, we can also add columns without grouping stuff. So with mutate, we can add a new column, a calculated column, if you want to say like that. And we can calculate a margin, and the margin would be the sales amount from my data frame minus the total cost of my data frame. So we get a new column at the end here. If we scroll up, we see the name of the columns. Here we go. So there's the sales amount subcategory, blah, 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 all the values from the data frame, and margin at the very end, which is calculate the sales amount minus total product cost. And last but not least, for this introduction to data frames, I create a simple data frame, df1, but very creative with the naming. One column is called customer ID, the second is sales amount ID with different numbers here. So we have different customers with different sales. Some customers have more sales. And I have a second data frame where I have different customer IDs, so 1, 2, 4, while I have sales for 1, 2, and 3, so that we don't have a sale for customer 4 and on the one hand, and on the other hand, we don't have a name. So we have names for the customers. We don't have a name for customer ID 3. So I can show you how you can do the different inner and outer joins. We can do an outer join. That means show me all the rows from both data frames. If they have the same custom ID, put the things in the same row. If not, put in different rows. So merge with all true shows me the list of the repeating custom IDs here. And for 1, we have a sales amount of 20 and the name of X. The name stays the same for the second row. For the third customer, we don't have a name. That's why it is not available. You remember the first part of this 60-minute talk. And for customer 4, we don't have a sales amount. That's why it is not available, but a name. Now we can play around with left outer join, for example. Left outer join means I'm passing in X is the data frame 1, Y is the data frame 2. I want to join by customer ID. So every time the customer ID has to be the same. If the for a customer ID for the data frame 1, which is X, is there, but there's no value in the second data frame, I still want to see it. So all X is true. I want to see all the rows from the X data frame, which is the first data frame. So we get a list of all the customers from the first data frame. But if there's no row in the first data frame, I will not see the row. So we don't see the customer 4 now, because the customer 4 is not existing in the customer ID values of the first data frame. The red outer join would be put the things the other way around. So all Y, make sure I get all the rows from the second data frame. Y is the second data frame. And I see here, now we get the customer ID 4, but not the customer 3. Very unusual is the cross join. I really do this also in SQL classes. I'm showing this, but I can't remember of a single productive code I'm using a cross join. So cross join means to take every row from one data frame in this case and combine it with every row from the second data frame. So I have the customer ID 1, 2, 3 here. So this is like the content of the first data frame, and this is combined now with all the rows from the second the second data frame. So this is now combined with the customer ID 1. Then I have the same repeating for customer 2 and customer 4. Doesn't make any sense in most of the scenarios. And the third or the last example here is the inner join. So we've seen the full outer join, the right and the left outer join, the cross join. The inner join will only show where the customer ID is the same, where the row is available in the first and the second data frame. That means you only see customer ID 1 and 2, because 3 is available in the first data frame but not in the second, 4 is in the second but not available in the first one. That's why we end up with this list. More examples here, not concerning data frames, but concerning what we can do with R. So the interesting stuff, now we know the syntax. Now we had heard that data frames are really important and how we can query and clean up data frames. One real world example would be using this package Profit. The package Profit was written or it is provided by Facebook. The data science team in Facebook, they wrote this package, and the name says it all. It's a time series prediction. So I can pass in a data frame with values for different points in time, and it will predict them for the unseen future. And that's what we were doing here. So the factory result sales is one of my example data frames here, and I'm using the order date and the sales amount. So a list of dates and the sales I had on those dates. That's what I'm passing in here. And then I have to rename the columns. So the profit package is rather picky. The date column always have to be named DS, and the value column is always Y. This is given by the package. That's why I have to rename this. And I find it rather funny to rename stuff. So there's this call names function. If I call names and pass in my data frame, I see the names of the columns in my data frame, order date and sales amount. And by left assignment, a new array, I can rename the column names. So I'm passing it to the return value. I can pass on values on the return value of a function. I've never seen this in other programming languages. So if I execute this line and I call names again, you see now the column names are renamed to DS and Y. Order date becomes DS and sales names becomes Y. Then I'm doing a little bit of cleaning because this data comes from is a CSV file. So there's like the data is in a text format, and to make sure this is the right format, I call the sposixcd function, and then I convert everything. So the demo data consists of data where, for example, for February, I have one value in the 10th of February, and for March, I have two values, one on 15th and one on 20th, and I cannot do daily predictions on that. So what I'm doing here, I'm overwriting the day in my date time. So I keep the year, I keep the month, but overwriting the day to the first of the day, and then using dplyr to combine everything to group by on the date. So I got only one row per date, which is the first of the month, which consists of the sum of all the sales in this month. Then we're starting building up our machine learning model. By calling Profit and passing in my data frame, now Profit is applying machine learning, and it's learning from the data. It tries to find out the trend, the seasonality. It tells me that here the weekly seasonality could not be discovered, of course, because there's no weekly data, it's only one per month. Then I build an empty data frame, make future data frame, and this future data frame should be fit for my profit model, the model I just created here, for the next 6 periods. and the frequency is months. So I want to do a prediction for the next 6 months. And then I do the predictions with predict. I'm passing in my model. That's the thing. Model is the thing which learned from my data, and passing in the empty future data frame. So now it can do the prediction into the empty data frame, and then merge both the existing data and the predicted data, and I get my predictions here. So for the last row, so we have not available here, but for the last 6 rows, 1, 2, 3, 4, 5, 6, I see there's a predicted value for y hat y. That's the predicted value for y. For this value, we already have the actual value and also prediction. So Profit provides me not only with the prediction for the future, but also a prediction. It's also applied the same model to the current data, and this makes it easy to see if this is really working good or not, because I never know for the prediction how good is the prediction, because we don't know the we see the predicted values, but we don't know how the future will actually be like. But for the past, we know how the past looked like. And if I apply the model for the past, I can see how good is this model working. Speaking of how to see how good it is working, we come into the plotting functionality in R. So I'm using here ggplot. This is the grammar of graphic, and that's the first plot thing I started with, and I really like it. So I stick with that. There's plenty of other ways of plotting. There's also plenty of other packages out there to do your time series predictions, but that's what I used in the first place. And as long as I find my solutions with that, I will stick with that. And this is my recommendation. So find something which is working for you, and as long as it's working for you, keep it. And if you hit the limitations, then look out for another package to explore if this finds a better solution for your problems. In the scales package, make sure that we don't get the numbers in scientific format, but see the real numbers, like 5 million would be 5 and 6 zeros, and not the 5E6, the scientific notification. So ggplot is working like that. I'm passing in my profit forecast. So this is my new data frame consisting of the actual values and the future values. I'm passing for the aesthetics. Yes, is this aesthetics. I want to see the dates on the x-axis and the y, the actual values on the y-axis. The first color I'm good with. Draw a line. Show me the points in the line. Make everything bigger so it's easier for you to read. For the y scale or the y-axis, I said this is a continuous axis, and the value should be between 0 and 5 million. And I want to have commas. I don't want to have the scientific notification notation for the numbers. And then again, we'll call geom_line. So I have a line now for the actual values. I want another line and points, but this time not for my y values, but for the y hat y. Y hat y is the predicted value from profit package in a different color. No legend, and the labs, the labels on the x-axis should be named order date and sales amount date. If we do this, we get this tiny line chart here. It's hard to read. I could make it bigger by moving this around, but the best way is to zoom, so I get a different second window, and I can make this big, and then everybody can see my numbers here. So the blue dots are the current values in my data model. So they are going up to 2013. That's what I have in AdventureWorks. Old data, I know. And the prediction goes for another 6 months. So show me how this is predicted. Is this good or bad? There's different ways of calculating how accurate a machine learning model is. But alone from looking at it, sometimes it's really close. It's almost spot on like here. But on different occasions, it's rather far away, like here or here, with a sort of a distance. So what the model does, or like in the beginning, what the model does is it finds a trend and it tries to find seasonality. As we have monthly data, it tried to find monthly seasons. And if you look here, so my first name is Marcus, so I always see M's, easily M's in patterns. So like, does it look like an M? I hope everybody can see this. Looks like an M. This M is repeating up there. So it's the same pattern 12 months later. And here we again start with this M-shaped thing, but it's not continued because I only ask for 6 months, and this is reaching out. So that's how this is working. And depending on how good seasonality could be discovered in the past and how good this is discovered seasonality is also true for the future, as good your prediction will be. I did this for a real-world project, and there we predicted the most important key performance indicators, and we did a daily prediction for the next 180 days and kept all the predictions. So we could also see how the predictions adapted, and this was really, really accurate. I mean, you can also tweak the profit model. You can change different parameters. I wanted to show some instructional stuff, so you can really tweak this. And this is really, yeah, amazing how good these predictions can be for the time series. Before I return to the slides and wrap everything up, 5 minutes to go, I want to show you two different things. One is you can have all the R scripts also run in Power BI, for example, my favorite tool at the moment. So this is the same picture we already have seen. Then colors are a little bit different because I adjusted them to my report here. And if you take a look, you can see that here in Power BI, so this is Power BI, I have a visual, and inside the visual, an R code is running. This is the same R code we already have seen. I walked you through the R code. This is the R code I just copied and pasted in here. So I did not develop the code here. I developed it in Rstudio. Copy and paste it in here, and then we can have R visualizations. In this case, not only the visual, but also the time series prediction in this visual. And if you think, I don't want to run this every time somebody sees something, I want to prepare that, then there's two possibilities. One would be inside of Power BI, for example, you can run an R script also in Power Query. So Power Query shows the applied steps, and you see that as part of my transformations in Power Query, I ran an R script. And this R script, again, I'll make this, open this up, is running my script about the profit. So I'm loading the profit package, and then I'm summing up everything, doing the stuff there. So then the script is only run once if you refresh the data, and the data is then persisted in your data model, and then of course you can make your predictions, your visualizations on that. If you're not into self-service BI, but you want to persist the data somewhere in the system, in SQL Server, this is rather easy. In SQL Server, you can run an R script. Since if you're using SQL Server 2016 or later, then you can run SP execute external script. And there's one parameter, the language. In 2016, only R scripts are allowed. With 2017, we got R and Python scripts. And with 2019, we are allowed to run R, Python, and Java scripts. And then you pass in the script. Again, this is not really a real editor. You just pass in as a string value the script. As you can see, this is a simple script. It's just copying the input to the output. Where is the input data coming from? It's coming from a SQL query. So this time we don't have to export the data outside of SQL Server, but keep the data inside of SQL Server and move the script to SQL Server. So we're running the script on SQL Server, and the output data set, that's the name, that's a fixed name, which is then returned as a result from the script. We have to state how the data types look like for those columns. So this is how you can use this in an enterprise solution. Let's go back to slides. So I did show you already that you can integrate in database engine. You can also integrate it in Power BI. There is less integration services. Of course, you can always run the SP execute external script, and that's what you're doing here. The same is true for the paginated reports. You can not only run a query in reporting services report or paginated reports, but you can also call a procedure, and I would write my own procedure, and the own procedure would then call the SP execute external script procedure and parameterize it. You could also run R in Azure Machine Learning Services. Unfortunately, because of 60 minutes time limit, I could not show you that, but you can also build your own scripts there. You can build your models. You can use R for transformations. So why would you integrate R into anywhere? Because you then don't move the data, but move the script. And you can run resource governor on SQL Server to limit the resources used so that your SQL Server applications still have enough resources. And security is a big issue because if you export the data, it's hard to stay in control who and when and why this data is accessed. If the data doesn't leave SQL Server, it's easy to maintain that. And of course, you can operationalize your models because you can run the script directly on SQL Server and enrich your data you already have on SQL Server by the new predicted values. You can cluster the customers, for example. You can do these predictions and store it on SQL Server. And everybody who has access to SQL Server can then use these newly calculated numbers without any knowledge of R. There are some pitfalls you see here that I always forget about case sensitive. I always, at least in the beginning, I was confused that dot is not a special, has not a special meaning. And I'm also sometimes confused when to use quotes and not. So please check them out. If you see weird error messages, maybe it's because you didn't think about case sensitivity, or you did put the quotes or forgot the quotes. The conclusion is R is easy to learn if you already know a language like SQL. It has only a few standards, but a lot of packages, and it's really fun to dig into this stuff and apply cool machine learning stuff there. R has its use cases, as we have seen. So like every programming languages, there's a pro and contra, and for doing machine learning stuff, for visualizing data, R really is great compared to other things. And it's integrated in the Microsoft's data platform. I did show you Power BI and SQL Server, but there's also other tools where it's there, so it's worth to learn. Before I run out of time, here are the instructions. Are there any questions? Don't see anything in the chat. Please use the chat if you want to ask me questions. Other than that, if you come up with a question later on, or if you see the recordings, please reach out to me on Twitter, on LinkedIn, via email. I'm glad to answer your questions you have according R and the integration into SQL Server. If there are no questions, I wish you a really good rest of the day, a really good week, and hope to see you soon in another expert talk at Skill Me Up. Thank you very much.